Let us quickly move through the summary of all losses. Friction loss is calculated using this formula. Loss is equal to mu alpha plus kx into initial pre-stress. Next is anchorage slip loss. Loss is equal to del A into ES divided by span of the beam. Next is elastic deformation loss is equal to M into Fc, where M is equal to modular ratio, Fc is equal to pre-stress. Next is shrinkage loss. Shrinkage loss is calculated using this formula. Loss is equal to shrinkage strain into Young's modulus of steel. And last one is creep loss using approach 1. When creep coefficient is given, you have to use this formula. When creep strain is given, you have to use this formula for calculation of creep loss. Finally, relaxation loss. Percentage of relaxation loss is generally given in question. Let us solve one problem related to the calculation of losses. The question was asked on May 2018 for 16 marks. Let us read this question. What exactly the given data as well as what you have to find out. A post tensioned concrete beam spanning 10 meter and having cross sectional area 200 mm by 300 mm is pre-stressed with cable having an area of 320 mm square located at constant eccentricity of 50 mm. Initial pre-stress in cable is 1000 Newton per mm square. Calculate percentage loss of pre-stress in the cable using relaxation of steel is equal to 5%. Shrinkage strain is equal to 2 into 10 raised to minus 4. Creep coefficient is equal to 1.6. Frictional coefficient is equal to 15 into 10 raised to minus 4 per meter. Anchorage in slip is equal to 1 mm. Young's modulus of steel is equal to 210 kN per mm square and Young's modulus of concrete is equal to 35 kN per mm square. Let us solve this problem. So first you have to sketch the longitudinal and cross sectional view of a beam. So this is cross section of beam with 200 mm width and 300 mm overall depth. This is the CG of concrete. Let us sketch the longitudinal section also. From that section you can clearly show the profile of the tendon. The beam is of 10 meter. Okay, and the location of tendon is exactly 50 mm from the CG of concrete. So this is your CG of concrete. From CG of concrete the tendon is 50 mm below. In cross section also you have to show the location of tendon. It is again 50 mm below. The tendon profile is straight with a pre-stress 1000 Newton per mm square. So let us calculate first loss is the friction loss. We know that there is one direct formula to find out the friction loss. Friction loss is equal to mu alpha plus kx into initial pre-stress. So here mu and alpha term is 0 because the tendon profile is straight. Then the value of k is given. The value of k is friction coefficient 15 into 10 raised to minus 4 per meter. This value is given in question. Okay. So the loss is equal to this mu alpha term is 0. You have to put directly this term 15 into 10 raised to minus 4 multiplied by x. X means the distance from jacking end. Let us consider this as jacking end. So from this end you have to consider the x, and x is the distance from jacking end where the maximum loss is developed. So at remote end generally maximum loss is developed. So in this case the x is equal to 10 meter. Directly I have to put here 10 meter. Okay, because the frictional coefficient 15 into 10 raised to minus 4 per meter, this meter get cancelled, and you have to put now initial pre-stress. Initial pre-stress is 1000 Newton per mm square. After multiplication we get the value. It is 15 Newton per mm square. 15 Newton per mm square is the friction loss. Newton per mm square is the friction loss. Next is you have to find out the shrinkage loss. Next is shrinkage loss. So this loss is calculated using this formula: shrinkage strain epsilon sh into Young's modulus of steel. So the shrinkage strain given in question, that is 2 into 10 raised to minus 4 multiplied by Young's modulus is 210 multiplied by 10 raised to 3, because the given value it is in kilonewton per kilonewton per mm square. So you have to convert that value into Newton per mm square. The multiplication is 42 Newton per mm square. So this is the shrinkage loss. Next is creep loss. Next is creep loss. So creep coefficient is given. So you have to use the formula which having creep coefficient phi into m into fc. Okay, let phi is equal to creep coefficient, it is 1.6 given. Okay, m is equal to modular ratio, this is Young's modulus of steel divided by Young's modulus of a concrete. Okay, it is 210 divided by 35. Okay, so answer is 6. Now how to find out the fc? Now how to find out the FC? So FC is the stress in concrete at the level of a tendon. Okay, we know that P by A, okay, and plus P into E divided by Z. So P is equal to pre-stressing force in question. Pre-stressing force is directly not given. Pre-stress is given and area of wires are given. So pre-stress is 1000, area of wire is 320 Newton per mm square. So simply the multiplication is 32. Simply the multiplication is 32,000. It is in Newton. It is 32 kilonewton. So FC is, it is it is 320 kilonewton. Okay, 320 kilonewton. So 320 into 10 raised to 3 divided by 200 into 300 is the cross-sectional area of concrete, plus 320 into 10 raised to 3. Okay, so eccentricity is 50 mm, we know that, divided by what is the Z? So Z is equal to I by Y. So I is equal to 1/12 BD cube. It is the moment of inertia with respect to x-axis, divided by Y is the distance of tendon from the siege of concrete. It is 50 because you are calculating the FC at the level of tendon. So let take these values. Okay, so this is 5.33. Okay, let's calculate this. It is 1.77. So 5.33 plus 1.77, the value of FC is 7.1 megapascal. Okay, now we can simply calculate the creep loss. So loss is equal to, creep coefficient is 1.6, modular ratio is 6, 7.1 is the FC, 1.6 into 6, 7.1, the answer is 68.16 megapascal is the creep loss. Okay, next calculate the anchorage slip loss. Next is the fourth one, anchorage slip loss. Okay, loss is equal to del A into ES divided by span of the beam. So anchorage slip is given in question. Okay, anchorage slip is 1 mm multiplied by ES is 210 into 10 raised to 3 and span of the beam is 10 meters. So now here you have to put the value in mm. Okay, so 210 times 3 divided by 10,000. The answer is 21 Newton per mm square. And last, fifth one, relaxation loss. Last fifth one, relaxation losses. It is 5% of initial stress. It is the 5% of initial stress. 5% of initial stress. It is 5 divided by 100 into 1000. The answer is 50 megapascal. Answer is 50 megapascal. Okay, now you have to add all these losses. You have to add all these losses. So first loss is friction loss. Second is shrinkage loss. Third one is creep loss. Fourth one is anchorage slip loss. And fifth one is relaxation loss. The total is 196.16 megapascal. So finally the percentage loss is how to find out the percentage loss? So total loss divided by pre-stress. Total loss divided by pre-stress multiplied by 100. So total loss is 196.16. Pre-stress is 1000 divided by 100. So finally is 19.61% total percentage loss.